Hi students, welcome to Year 10 Science and the physics topic of motion and energy. This is video number 7 on energy transfers and transformations. So the last couple of videos have been focusing on Newton's laws, and now what we want to try and do is look at some of the other aspects of motion, where we are looking at how forces can cause motion, but also how energy can be transformed during the motion of different objects. In particular, we can look at how energy can be transformed from one form to another. So let's quickly just recap perhaps energy in case you've forgotten a little bit about what energy is. So from a physics perspective, energy is the ability to do work. Now, we also probably know that energy can be transferred from one object to another. That is, a particular type of energy can be moved from one object to another. This often happens when you are, for example, using dominoes, and when the dominoes fall, the movement energy of one is being transferred into the next. But that transference of energy can also occur as a transformation. And so whilst transferred energy might be the kinetic energy of object 1 turning into kinetic energy of object 2 as they collide with one another, energy can also be transformed, for example, from potential energy into kinetic energy. This is a transformation, and it's slightly different. And the unit of energy is the joule. In fact, most of the energy that we're going to be looking at is in sufficiently large amounts that we're going to be talking more commonly about kilojoules rather than joules, but it's worth knowing that the energy unit is the joule. So there's a couple of important types of energy that we need to look at, and obviously if objects are in motion, and this topic is about studying objects in motion, then the most important type of energy that we're after is kinetic energy. Kinetic energy is the energy of motion, and it's calculated by multiplying the mass of the object by its velocity squared and then halving that value. So Ke equals a half mv squared. All moving objects possess kinetic energy, and from this equation we can see that if the mass is large, then the kinetic energy will also be large. And if the velocity is high, that is, the object's moving very quickly, it will also have a greater kinetic energy. The other important type of energy is potential energy. And one of the most common types of potential energy is gravitational potential energy. Potential energy is energy that is stored, that is, has the potential to be released, hence the term. There are a number of different types of potential energy. Gravitational is again the one that we've explored a little bit in class already. We've also looked at elastic potential energy when we looked at our little Barbie bungees, and chemicals themselves possess an amount of energy that can be released during chemical reactions. Each of these is a type of potential energy because it's stored within the object to be later released or transformed into another form of energy. The one that we're going to look at in a little bit more detail for the next little while, couple of weeks, is gravitational potential energy. Gravitational potential energy can be found by multiplying the mass of an object by the value of acceleration due to gravity by its height. I have to do work on an object. I have to add energy to move that object against the gravitational field, that is, to move it up. And as I move it up, it moves to a position of greater gravitational potential energy. Of course, if I let go of it, that potential energy will then be converted into kinetic energy. And that's really what I want to say about the conservation of energy. The law of conservation of energy tells us that energy can't be created or destroyed, only changed from one form to another. Now, there is a little equation that kind of makes a bit of a problem of this, and we will just ignore that for the moment. Even though I've put it there, I am aware of it, but we're not going to talk about it now. What we are going to talk about is balls being thrown into the air, falling off the edge of a balcony, and how the energy that's contained within those balls can be converted. We also know that at any point in the flight of a ball, as it goes up and as it comes down, we have kinetic energy and we have some potential energy. And these values change throughout the entire flight of the ball. What we do know is the total amount of potential energy and kinetic energy at any point during the flight is a constant. Now, as we've talked about in class, one of the problems looking at analyzing motion is there's a lot of things that can actually draw energy out of the system or change the net forces that are acting. And air resistance is one of those. It's a type of frictional force. It creates resistance against the motion, and it produces heat energy, which means that our systems are not always 100% efficient. And we can use a fairly simple equation to calculate energy efficiency by dividing the desired energy out by the total energy in and multiplying that by 100. But what we're going to be doing is having a look at a few different examples of how kinetic energy can be converted into potential energy and vice versa, and how we can use those values to calculate velocities. But we're going to do that in class. Thanks for watching.